Hello everyone, this is my lecture number 50. This is lecture 50. We have already learned the main components of the building. Now we'll try to understand the staircase. So my topic is staircase, that is design of a staircase. Staircase. There is some terminology in the staircase. Let us try to understand. इसको समझने की कोशिश करते हैं. जैसे आप staircase के बारे में सोचते हैं कि that is the longitudinal staircase that may have like this. This is landing, then slope, this is landing. This is a straight type of staircase. So this is provided something like this. This is going like this and this way. So this is supported by some beam, maybe here some beam, and this is going like this on the support. There may be support, and this may be some beam or something like that. This part is called the landing. This is your west left, west. This is your west. This is your west. This is soffit. This is again landing, and these are the steps we have. We can have steps something like this. These are the steps. So this total, this is called the trade, and this is the riser. This is the riser and trade. So this is a configuration of a longitudinal staircase. So we have a different type of staircase. So maybe longitudinal, straight way, maybe something dog-legged, maybe dog-legged. Dog-legged means if you provide some sort of beam over here, starting, suppose we have some beam, then we have proper, say this part is covered by wall. We have got some landing over here. This is wall portion. So we have some landing over here, and there is gap. This gap. These steps are equal. Like this up. This is A. This is your like this going this way. This is down up. So this is your B. This is your masonry wall, and this gap is not more than 150 mm. Not more than 150 mm. So this is called the dog legs. The steps are, suppose this is some numbers, this may be 10 numbers, then this will be also 20 number. So this steps is provided in the public building. So this is called the dog leg, open navel. If the space is increased more than 150 mm, maybe provided for lift or something like that, lift space, then that is called the naval staircase. So the space is increased in between and can be provided for air ventilation or for the multi-story building. The lift is provided in that space. This quiet space is left around, so that is called the navel. So we have got a different type of stairs हम लोग पास है. तो हम यहाँ पर क्या है टर्मिनोलॉजी के बारे में अगर डिस्कस करना चाहें तो ये चीजें थोड़ा सा डिस्कस करके कर सकते हैं. जैसे आप यहाँ देखेंगे स्टेयर में, तो स्टेयर के कंपोनेंट्स में जनरली अगर आप थोड़ा सा आर्किटेक्चरल पॉइंट ऑफ व्यू से अगर चीज़ों करते हैं तो वी हैव गॉट समथिंग वी कैन हैव इन दिस वे. दिस इज गोइंग समथिंग लाइक दिस. In this way we are making some nose. This is your riser and this is going west, something like this. One step is shown, one step. This is your west. This is your west configuration. So this point is shown like this. So this is vertical member. This is vertical member. If we provide some bigger size like this, so this is your point layer and this is something like this way, in this way. This part you can say this is a west, this is W west, and this total length is called the tread. This is your tread, total tread. And this height which is vertical, that is called the rise. And this is called, this point is called nosing. And this part is called going. So tread equals to nosing plus going. So this can be provided for the architectural point of view, edging, or in the public building, the edges can be affected, can be distorted. So instead of this, we provide some nosing. So this is your nosing, something you are providing in this slab. You are providing some sort like this. This is going in this way. This is your riser. So this part is called going, and this part is called nosing. So this is part called nosing. So we provide in this way. In this way, the stair is provided something like this, and this is your rose. This is your rise, and this is your going and nosing. So in some of the stair, this nosing may be provided, may not be provided. It depends on the that is the design of architectural design of the stair. So this you will find nosing and going this way. Let us discuss the terminology of this staircase. We have got one thing, that is flight. Number 2, landing. Number 3, steps. Number 4, you can say riser. Number 5, you can say tread, or you can have going, and you have nosing. And we have got west, slab, or we can have soffit. And the railing part is another. तो railing नहीं डिस्कस कर रहे हैं, balustrade and all we are not discussing. So actually the height of any building, this is a height, maybe 3 meters or something like that. So to cover this height by steps, we provide the stairs. So stair is provided to cover this height. Maybe in this way, this is 2.1 meter, suppose kariye. This is 2.1, 7 foot. So we'll go for 7 foot like this. In this way. In this way, we can go something like that. We can go like this. In this way. This is a stair. So this is landing, and again we can have something like this. In this way, we can have far more steps. In this way, we can have, this is your height. So suppose this is your height. This height is covered in this way, in this way. So we are going like this, like this, like this, like this, and like this. So this is your landing part. This is your wall, maybe wall, something like that. So this height is covered by 2.1 meters. Same as remaining height is covered. This is your 150 mm thick, and so this height total will be 3 meter. This overall meter is covered 3 meter. So in this way, we are reaching to the rooms or slab. We have maybe some door, maybe slope. This is your door, maybe something like so. Landing here. So you are reaching to the first floor. This is your first floor, maybe. This is your ground floor. So to reach from one floor to another floor, we arrange the stairs. So stair, by providing landing is space for rest or to divert the directions of the stairs. So this stair can be of different way. Maybe this can be stair something like that. You are going in this way, stair in this way going, and this can be bifurcated. You are landing, so this can be bifurcated like this. In any direction, this can be bifurcated. So this is bifurcated. This can go something in this way, or this may be going on 4 sides. So this is bifurcated. So stair can be provided in different shape, different sizes. It depends. This may be circular, this may be spiral. So these are the different type of stair. So we have got these terminology, that is flight. So this distance from here to here, this is called the flight. This is called the flight. This is distance is covered the flight. And this is your landing. This part is your landing. This part is your landing. And this, the thickness of the vest is called the thickness of vest. That is the vest. The thickness of this slab is called the vest slab. That is vest slab of staircase. And the steps is considered riser and trade. This riser and trade, one riser in complete trade is called the step. How many steps? So riser and steps. So this is called the steps. This is going as we have already explained. If you suppose in the west we provide some notching in this way. So this part is called the notching, and this part is called going, and whole part is called your trade. This is trade. So this is notching. This notching is extra. It may be some sort of your flat, your channel, something is provided. Some architectural point of view, this strip can be provided at that point. So this portion is called the edging, so that the edge of this going should not be distorted. So this is provided something like that. So this is called going, this is called the riser, this is your vest, this is your vest flap, and soffit. This bottom portion is called the soffit. This bottom portion is called soffit. Now let us discuss the riser and trade अकॉर्डिंग टू कन्वीनियंस. हमारी सुविधा के हिसाब से हम राइजर ट्रेड रेजिडेंशियल बिल्डिंग में कितना रखेंगे और कॉमर्शियल या पब्लिक बिल्डिंग में कितना है. तो रेजिडेंशियल बिल्डिंग में हमारी हाइट जो है मेन होती है रेजिडेंशियल बिल्डिंग में, और हम कितना स्पेस प्रोवाइड करेंगे उसके हिसाब से है. तो जनरली हम रेजिडेंशियल बिल्डिंग में राइज जो है वो 160 mm के आसपास 160 to 170 रख सकते हैं, और ट्रेड जो है वो 200 से लेके 230 तक प्रोवाइड करते हैं इस तरह से. इसी तरह से कमर्शियल अगर आपका है, कमर्शियल में हम राइज को थोड़ा कम करते हैं. दिस कैन बी 120 mm to 150 mm sometimes, is reduced very much. Sometimes it's 100 mm also provided, and trade is put 270 mm to 300 mm approximately. There is one thing, 2 rise plus T is provided more than 550 to 700. So we can arrange in this way that to see the comfort को ध्यान में रखते हुए riser or trade. If a riser is less, then this is more comfortable, and for the foot this is 9 inch. So 9 inch is 200 is 8 inches, so is less. So we let us provide 9 inches to 12 inches for the trade, so that your foot can be properly taken up by the trade. So according to in commercial we provide almost 12 inches. So 12 inches 300 9 is 10 to 12 inches. This is 10 to 12 inches is provided. 11, 12. So this according to comfort this can be provided. Now let us see how the this staircase is designed. तो staircase को डिजाइन करने के लिए IS 456 ने 455/2000 ने एक तो स्पैन के बारे में बताया. जैसे सपोज करिए कि इफ यू प्रोवाइड द स्टेयर इन दिस वे, द बीम सपोर्टेड बाय बीम इन दिस वे, दिस इज सपोर्टेड बाय बीम, समथिंग लाइक दिस. सो if you provided by beam and this is something like this, so the span is taken as center horizontal distance. This is this horizontal distance center to center. So there are some cases, there are 3 cases. One that is effective span of stairs. If you provide some stair, suppose करिए if you provide a stair something like this, this is your part of stair. So we are providing in this way. Suppose करिए we are providing stair something like this, in this way. So we are supported at top and bottom riser by beams like this. Top and bottom riser. This is your top riser going in this way. So the center distance will be taken. We are supported top and bottom riser by beams spanning parallel to riser. The distance center of beams. Center horizontal distance center. In this case यहाँ पर जो आपका केस है इसमें सपोज करिए 2 लैंडिंग आप प्रोवाइड करते हो यहाँ पर इस तरह से कोड के हिसाब से. सेंटर डिस्टेंस मान लीजिए कि दिस इज योर, सपोज करिए This is your x, this is your x half, this is your y, and this is your y half to half, or this is your flight, this is the horizontal distance, whatever it may be. This is called the, in bigger way, this is going. Not for the small one riser, this is going for pole, this is going, this is horizontal distance, this is horizontal, and this is your, whatever distance is divided in two parts. This is divided in part. If x is less than 1 meter, y is less than 1 meter, then the span will be going plus x plus y. If x is greater than 1 meter and y is less than 1 meter, span equal to g plus y plus 1. If x is greater than 1, put 1. If y is greater than 1, x is greater than 1, then span is equal to g plus 1 plus 1. So, if suppose karo x is less than 1 and y is greater than 1, so s equal to g plus 1 plus x. So, according to code, we can have the span in this way. So, this is the all about the span. Where the landing slab spin in the same direction as the slab, they shall be considered as acting together to form a single slab, and the span determined as the distance center of supporting beams or walls, the going being measured horizontally. तो इसमें भी इस तरह से हम केसेस में स्पान को कैलकुलेशन कर सकते हैं. सपोज करिए तो ये इस तरह के केसेस आएंगे जिस पर कि हम इसके स्पान को डिसाइड कर सकते हैं. अब सवाल उठता है कि हम स्टेयरकेस को एग्जाम्पल के माध्यम से समझने की कोशिश करेंगे किस तरह से इसको डिजाइन किया जाए. थोड़ा सा लंबी प्रॉब्लम जरूर हो जाएगी, लेकिन लेट अस ट्राई टू सॉल्व वन प्रॉब्लम. So this is example, arrangement of a dogleg staircase is shown in figure 1 for a residential building, rise equals to आपका है 160 mm, trade equals to 250 mm, M20 grade of concrete, Fe415 of steel. We are providing HYSD Fe415. So डॉगलेग का एक अरेंजमेंट हमारे पास है. तो लेट अस सी हाउ दिस विल बी डिजाइन. हम यहाँ पर अभी डिस्कस करेंगे. तो लेट अस सी समथिंग लाइक दिस. This is provided in this way. This is your landing. This is again your landing. This way we have got, this is 150 mm. The number of steps are 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is your 10. This is 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 1, this is 10, this is 11, this is 20. So they're going up. This is landing A, this is your landing B, this is your 100. We are providing some sort of beam over here. This is provided. This is distance. So this is your brickwork. This is your brickwork. This is your beam. by 300 mm. This is your 300 by 300 mm. This is your brickwork. 230 mm. This is again 230 mm. Distance is, this is 900 and this is 900. This is your 2250 and this horizontal distance equals to your this is 900, this is again 900, this is 150. This is arrangement of a staircase, 300 by 300. This is 300 by 300, right? So this is 300 by 300, being 300 by 300, and this is landing. This is 900. This is 900. And this is the arrangement of the stairs. This is dog leg stair. इसमें 10 स्टेप हैं. We are 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 is 10 this side and 10 this side. This is 20, total 20 stairs. So 10 stairs हैं. 10 stairs. One flight, and 10 stairs in another flight. So step distance is equal to horizontal distance is covered is how much? This is coming. The riser is 160 mm and 250. So this is coming 2250. 2250. This is 9 steps. 9 and 10. So this is your 10 step. The riser up to here. This is 9 steps. So 9 into 250. This is 2250. So actual steps is something like that in this stair, in this way. it is going in this way, like this. So number of steps here, 1, 2, 3, 4, like this. This is going in this way. So this is 9 stairs. 9, 1, 2, 3, 4, 5, 6, 6, 6. This 7. This is going like this. This. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is step. So riser is number 1, 2, 3, 4, 5, 6, 7, 8. This is 8. This is 9. There is 9 number. So this is your in this way. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, and this is your 10. So there is a 9. A 9 in this way, the distance is calculated is 9 multiplied by 250. So this is 2250. That is why this is 2250. And this length is your 900. 900. This is 900. And this is 900, 3 foot, 3 feet, and this is 3 feet. So this is like this. So let us try to visualize this thing. ये हमारे पास है और हम इसमें डिजाइन करना चाहते हैं. तो दो पार्ट होंगे. दिस is symmetrical, A and B are symmetrical. So the design for landing. For landing, we can A or B. We can then do the design of landing A or B. So let us take 1 meter strip. This is your 900 width. So we are taking 1 meter strip. We will take 1 meter strip. So span equals to 900 into 2 plus 150 plus D. D is the thickness of slab. Let us assume D overall is a 150 mm. So small d equals to D overall minus cover minus 5 by 2. Let us use 12 mm bar. So 150 minus 15 cover minus 12 by 2. So this will be 150 minus 15 minus 6. So this is 150 minus 21. So this is 129. This is 129. So instead of adding this 129, we can add this 150 also. So better let us provide D overall 1.50. This is added. So there is something like this. This effective D will be 129, but we are taking this. This is dependent on the span to depth ratio. For simply supported span to depth ratio, that is 20. And if you take some modification factor, maybe 1.5. So this span to depth ratio will be 25. So this span equals to your 1950 divided by 25. So we are getting 1950 divided by 25. This is coming 78. This is coming very less. 1950 divided by 20. This is 97. So this is coming very less. So instead of this, we are taking this 150 mm. Instead of you are taking 150 mm. So this is your overall depth, maybe 1800 plus 150 plus 150. So this is your 2100 millimeter. Now design loading in a 1 meter strip. So dead load equal to 0.15 thickness into 25. This is what. Let us take floor finish equals to 1 kilonewton per meter square. So this is your 0.15 into 0.15 25 3.75 kilonewton per meter square. So this is your level, that is 4.75 kilonewton per meter square is your total dead load, total DL, and live load for this can be 3 kilonewton per meter square. Live load for residential building is taken, residential may be taken 2 kilonewton per meter square for provision of not overcrowding. For family only. But this will be 5 kilonewton per meter square for overcrowding, maybe. Overcrowding. So we have taken 3 kilonewton. Yeah, you can take 5 kilonewton. Because it is residential, so we are taking this much. So this will be up to 7.75 kilonewton per meter square. This is for one thing. We have calculated 7.75. This is your span, this is 7.75. So we can calculate 7.75 or span is your 2.1 meter. Span equals to 2.1 meter and design load equals to 1.5 multiplied by 7.75. This will be your 7.75 multiplied by 1.5. This is your 11.625. This is your 11.625 kilonewton per meter square or 1 meter orbit. So we can design for this landing as we have designed this slab. So this part we can cover now. So this your moment mu equals to, that is W into Lx square by 8. You can take 8. This is simply supported. Maybe simply supported Lx by 8. So this will be your 11.625 multiplied by 2.1 square divided by 8. This is your how much coming? This is coming into 2.1 square divided by 8. This coming 6.40. This is 6.40 kilonewton meter. So for this you can design the reinforcement. Now the arrangement this can be provided for this mu is 6.4. So you can take mu equals to how much D we have. Mu equals to 0.138 FCK into BD square. B is equal to 1. So D equals to your root over this much, 6.40 into 10 to the power 6 divided by 0.138 into 20 into 1000. So this is your D required divided by 0.138 divided by 20 divided by 8. This is coming 232 10 to power root over 232. This is coming very 6.4, 11.625 to 2.1 into 2.1, 6.4 divided by 0.138 23. So what will do? 2318. 23 root over 2318. This is 48.14. This is coming 48.14 mm. 14 mm, which is less than 150 minus 21, that is 129. So we are taking 129. So this is less than. Okay. So let us find out the quantity of steel. This is coming 6.4, 11.625, 6.4. So XU by D equals to 1.2 minus root over 1.44 minus mu FCKBD square. This is your multiply by 6.68. This is your XU by D. So mu into 6.68 divided by FCKBD square equals to your 6.40 into 10 to power 6 multiply by 6.68 divided by your 20 into FCKB 1000 into D is equal to 129 square. How much you are getting? Let us find out this thing. So this is coming 6.4 into 6.68 6.68 divided by 2 divided by 129 inverse square. This is coming 10 to the power minus 3 multiplied by 1, 8, 2, 3. This is coming this much. This is coming 1.28. 1.28. This is coming 1.28. So this will be 1.2 minus root over 1.44 minus 1.28. This is coming 1.28. So 1.44 minus 1.28 gives out 0.16 root over 0.16 gives out 0.4. So 1.2 minus 0.4, this is 0.8. XU by D is equal to 0.8. XU by D equals to 0.8. So XU by D is 0.8. This is coming 0.8. So let us find out the AST. What is AST? Let us find out the Z. Z equals to your D 1 minus 0.416 into XU by D. This is your value. So D equals to D is common. 1 minus 0.416 multiplied by 0.8. So this is how much coming? Let us find out. 0.8. 1 minus 0.8 into 0.416 gives out 0.6672. This is your 0.6672 into D 129. This is your how much? Into 129. This is 86.06. This is coming 86 mm. Let's take it 86 mm. So 86 mm. Now let us find out the AST. AST equals to mu upon 0.87 Fy into Z equals to 6.4 into 10 to the power 6 divided by 0.87 into 415 multiplied by 86. So this is your value. So 6.4 divided by 0.87 divided by 415 divided by 86. This is coming 206.11. 206.11 mm square per 1 meter strip. This is, so what will be the spacing? The spacing equals to 12.5 A5 equals to A5 into 1000 divided by 206.11. So this is coming A5 12 144 into 0.785 113 into 10 to the power 3 divided by 206.11. So spacing coming 113 divided by 206. This is coming 44. This is coming 548. This is very much. This is 548. And then center. So we can provide 10 mm or we can provide 10 mm bar instead of 12.5. You can provide 10 mm also. You can provide 10 mm. So A5 is equal to 50, 78.5. This is your 78.5. 78.10,000 divided by 206.1. So this will be 78.5 to 206. This is 380. This is coming 380. So this is coming 380 mm center. So let us provide at a rate of 10 mm, at a rate of 300 mm center. Yeah, this can be provided. This can be provided. This can be provided. 210 mm, 300, 250. So minimum steel, let us check the minimum steel also. 206. Let us check the minimum steel. This is a very long problem. Minimum steel equals to 0.12 into D into D. This is 0.12 percentage. 100 multiplied by D is 1000 into D is equal to, let us take 150. So this is coming 150 into 0.12. This is 180. This is 180. So 180 mm square, which is less than 206. So let us provide 10 mm at a rate of 300 or it can be 250 mm center may be provided. This will be provided on the top. So this will be provided like this. You can check for shear and all. So this will be get satisfied. So you can check this thing. So 206.05, 206. your coming mu equal to 6.4 kilonewton meter, ES equal to your 206.11 mm square. Let us provide 250 mm center 10.5 here. So your ES will be provided will be your, that is 78.5 1000 divided by your 250. So this is coming how much? 78.5 divided by 250. This is 314. That is 314 mm square. So this is provided 314 mm square. So this will be put on the top because the main bar will go inside of the flight, and this will be put on the top. So this will be put on the top. So distribution steel will be provided. So distribution steel of, you can provide 8 mm 5 at rate of this, you can say 250 mm center. You can check distribution steel equals to distribution is equal to 180 mm square by 0.12 B into D percentage. This is your 180 mm square. So let us provide 8 mm 5, A5, 8 mm 5 here at a rate of 250 mm center. So how much will be this value? 8 mm means 64. This is 8 mm. 8 mm is 64 into 0.785. This is your 50. So 50 A into 1000 divided by 180. So how much coming? This is coming 50 divided by 180. This is coming 279. So this is coming 279. So we are provided center. We are providing at a rate of 250 mm center. So your AST will be 50 into 1000 divided by 250. So value will be your 50 divided by 250. And this is 200 mm square. This is 200 mm square. So distribution steel will be 8 mm 5 at rate of 250 mm center. So both sides, this landing and this landing will be covered. This landing and this landing will be covered.